This is going to be all about multiplying and dividing rational expressions. Okay. So last time we met, we were talking about rational expressions and what they are. And to give you a brief example, I told you that a rational expression is an algebraic expression with both a numerator, something on the top, and a denominator, something on the bottom. So it would look kind of like this. R of x is equal to P of x over Q of x, where Q of x is not equal to 0. Okay, because then we'd be dividing by 0, right? So we can't have Q of x be 0. Now, when you're multiplying and dividing, what you want to think about first is you want to think about what happens to fractions when you multiply them and divide them. So let's talk about it. Multiplying fractions. Okay, so when you multiply fractions, let's say we have fractions a over b times c over d, where b and d are not equal to 0 for obvious reasons. So when you have a fraction, you have a as the numerator and b as the denominator. Over here, you have c as the numerator and d as the denominator. What you have to do is you have to multiply across, right? You're going to multiply the numerators together to get a times c. And then you would multiply the denominators together to get b times d. And that's it. Now, when you're dividing fractions, what you want to think about is doing the same thing, but instead of multiplying across, you would flip the second fraction first. So let's talk about that. Dividing fractions. Okay, let's say you have a over b, and you're going to divide that by c over d. What would happen? Well, first, I'm going to say where b and d cannot be equal to 0, and c cannot be equal to 0. So what happens here is the first fraction is going to stay the same, so I write it out as a over b. But the second fraction is going to flip. This one is going to flip. And it's going to become d over c. So now we multiply. So a times d is going to give me ad, and b times c is going to give me bc. So that's how you divide fractions. You're going to take the second fraction, and it's always the second fraction. You're going to flip that one, and then you're going to multiply. And that's it. Okay. So I want to look at some of the problems from the problem set that I gave you. And I worked out all of them. You can see that on Canvas where I worked them all out on the modules. But what I also wanted to do was I wanted to go over them in more detail so you know exactly what you're doing. So let's go to the problem set. And I'm just going to work them out one by one. Okay, number one. Number one says 2x plus 8. And that's going to be over x squared plus 7x plus 12. And I'm going to multiply that by another fraction. X plus 3 on top and x plus 5 on the bottom. Okay, so I've got two fractions and I want to multiply them. The first thing I do is I got to make sure everything is factored. I want to make sure everything is factored so that I can start canceling out things later. So let's look at the top right here. Is there a number that I can take out from here that 2 and 8 have in common? 2 and 8 can both be divided by what? 2, right? So I can take out a 2. And I'm left with x plus 4. On the bottom, I can factor this as x plus 3 and x plus 4, right? I'm trying to find those two numbers that multiply to 12, but at the same time add up to 7. So now I write out my second fraction over here. Notice this one doesn't change because it's already factored, so I don't really have to do anything to it. Okay, so now I start canceling things out if they're the same on the top and bottom. So what's the same on the top and bottom? The x plus 4s, so I can cancel those out. What else is the same on the top and bottom? The x plus 3s, right? So I can cancel those out. So now, what do I have left at the top? I just have a 2. And what do I have left on the bottom? Just an x plus 5. And I'm done. So that's how multiplying works. You factor first, and then you start crossing things out, canceling things out, if they're the same on the top and bottom. And they can be the same on the same fraction, like the x plus 4s. Notice how they're on the same fraction, and if it's the same on the top and bottom, I can cancel them out, right? But also think about this. I've got x plus 3s on different fractions, but since they're the same on the top and bottom, I can also cancel those out. So you're always trying to cancel out as much as you can without making a mistake. Let's try number 2. All right, number 2. This one says x minus 2 on top. On the bottom, I have x squared minus 25. And I'm going to multiply that by x minus 5 over what? X squared minus 2x. Okay, so looking at this, I've got two fractions. I'm trying to multiply them, and I can factor some stuff on the first fraction, right? Not at the top, because the x minus 2 can't be factored anymore. But this x squared minus 25, we can write that as difference of squares, right? We can do x plus 5, x minus 5, and that's what I'm going to do. So let's rewrite the first fraction as x minus 2 on top. That hasn't changed, and we're going to write this as x plus 5 and x minus 5. And over here, the x minus 5 is going to stay the same on top, but on the bottom, what can I take out from here? What do they have in common? They both have an x, right? So I can take that out. That's my GCF. And what am I left with? X minus 2. Good. Okay, so now what can I cancel out? That's the same on the top and bottom. The x minus 5s, so those are gone. I can also cross out the x minus 2s, so those are gone. So what am I left with at the top? Well, I don't have anything else on the top, right? So I'm going to put a placeholder 1. So my final answer is going to be 1 over what? X plus 5. There's nothing else I can do to this. Okay. Let's look at number 3 on the problem set. Three says 4x to the 8th over what? 10y to the 7th. And we're multiplying by what? 5y cubed over 8x to the 5th. Okay, so for this problem, there's nothing that I can really factor, but I can start canceling out common factors, right? So let's start off with the 4 and the 8. And let me change my color to blue real quick. The 4 and the 8, how do those cancel out? Well, if I get rid of the 4, I have to turn the 8 into a 2. Because notice how we're dividing by 4 on the top and bottom. So if I get rid of the 4, the 8 is going to change into a 2, right? Because what's 8 divided by 4? That would be 2. Okay? Now let's work on the other numbers, the 5 and the 10. If I cross out the 5, what does the 10 have to become? So we're dividing by 5, right? 10 divided by 5 is going to be what? 2. That's right. So now the numbers are done. I don't have to worry about the numbers anymore. Now let's talk about the variables. Let's do the x's first. If I get rid of 5 x's on the bottom, and I can because I have at least 5 x's on the top, right? I can get rid of 5 x's, but what does the 8 have to become? The 8 is going to become a what? 8 minus 5, that is 3. Okay, so now the x's are done. Let's move on to the y's. I can get rid of 3 y's at the top, like this. But if I do that, I have to get rid of 3 y's at the bottom. 7 minus 3 is 4, so that 7 is going to change into a 4, right? I'm just taking away 3 from 7. That's it. Okay, so what am I left with? Let's start off with the top. On the top, the only thing I have left is an x cubed. And what do I have left on the bottom? Well, let's look at the numbers first. I have a 2 right here, and I have a 2 right here, so 2 times 2 is going to give me 4. And how many y's do I have left at the bottom? I have 4 y's, so that's going to be y to the 4th. And I think that's it on the bottom, right? So we're done. That's number 3. Okay, so no factoring involved right there. Now let's go to some of the division problems. Let's do number 4 together. Okay, so for number 4, I have 2 fractions. Let's just go ahead and write them out. We have x squared plus 10x plus 16. And on the bottom, I have what? X squared plus 6x plus 8. And we're going to divide everything by what? 1 over x plus 4. Okay, let me go ahead and zoom in on this. Okay, so remember when we were talking about dividing fractions, we said that we had to flip the second fraction? That's what we're going to be doing. So let me write flip. Because this is the one that I want to flip over, right? I'm always flipping the second fraction, and it's always going to be the second fraction that I flip. So before I do that, though, I want to factor the first fraction. So how does the top factor out? I've got to multiply to 16, but at the same time add up to 10. So I'm thinking 8 times 2. So that's going to become x plus 8 and x plus 2. So that's the top. What about the bottom? 4 times 2, I think that'll work. So x plus 4, x plus 2. I can already see what I'm probably going to cancel out, right? So that's the first fraction. And all I did for the first fraction was factor the top part and factor the bottom part. Now, the next fraction, I don't really need to factor because everything is already factored out for me. There's nothing to do. The only thing I have to do is, since I'm dividing, I have to remember to flip the second fraction and then change the division to multiply. So let's do that. Go ahead and change the division to a dot. That stands for multiplication. And we're going to flip the second fraction. So this is going to become x plus 4 over 1. Okay, so now what can I cross out that's the same on the top and bottom? We already talked about the x plus 2's, so those are gone. We can also cross out the x plus 4's, right? So now I've canceled out everything that I can possibly cancel out. So what do we have on the top after all this? We have x plus 8. And on the bottom, we have a 1. So if we're dividing that by 1, really that doesn't change anything, right? So I could write out my answer as just x plus 8. And I'm done. And we can only do that when we're dividing by 1, right? So that's number 4. Let's do number 5 now. And I'm going to need a new sheet of paper for this, so this is going to get going in a few seconds. We're going to be doing number 5 on the problem set. Okay. Let's do number 5. Okay, so 5 says, okay, x squared plus 7x plus 12 over x squared minus 9. And on the bottom, I have another fraction. So let me draw a really long line. And on the bottom, I have x squared plus 2x minus 8. Yeah. And on the bottom, I have 4x minus 12. Okay, so what this is this is a complex fraction. So let me write that out. This is a complex fraction. So what is a complex fraction? All this really is it's really just a fraction on top of a fraction, right? This is going to be a fraction on top of a fraction. So in other words, the numerator is a fraction and the denominator is a fraction, okay? So we have a fraction on top of a fraction. So what we're going to do for this is I want to write this out with the division symbol, okay? That's going to be important. So that way you can see, oh, we're really just dividing the top by the bottom. So I write out the top, x squared plus 7x plus 12. And on the bottom, I still have x squared minus 9. I haven't factored anything yet. We'll get to that though. And I'm going to be dividing this by what? The bottom, right? X squared plus 2x minus 8 over 4x minus 12. So this is really what I have. I have the top fraction divided by the bottom fraction. Okay, and this makes sense because when you think about a over b, where b cannot be equal to 0, what we're really doing is we're dividing a by b, right? So we have the top divided by the bottom. Now what I'm going to do is I'm going to start factoring and I'm going to start flipping, right? Because when we're dividing, we always have to flip that second fraction, right? So we're going to be flipping this in the very end. So let's factor the first fraction. We got x plus 3 and x plus 4 on top. Because once again, I have to multiply to 12 and add up to 7. And on the bottom, I'm going to have x plus 3, x minus 3, because that's difference of squares. Okay, so now what I'm going to do is I'm going to flip the second fraction, and I'm going to make it into division. So the top is going to be what? The 4x minus 12. I'm going to write that as 4 times x minus 3, just to take out the 4. And then on the bottom, I'm going to have that 4 and 2, but the 2 has to be negative. So x plus 4 and x minus 2. Yep. Okay. So what I did in that step was I actually did two things at once. I factored the top and the bottom, and I flipped the fraction. So now the bottom is on the top and the top is on the bottom. Now I multiply and I start cross canceling and canceling up and down. So what matches up on the top and bottom? Well, first of all, I see the x plus 3's match up, so I can get rid of those. What else matches up? The x minus 3's, right? Here and here. And what's the last thing that's going to cancel out? The x plus 4's, right? Those match up. So those are gone. So really, all I have left on the top is a 4. And the only thing I have left on the bottom is an x minus 2. And I'm done. Okay, so that's a complex fraction. Since I'm done with the problem set, let's go ahead and work on 2 problems from the classwork. And the 3 that we don't get to, that's going to be for your homework. Okay. Classwork. Okay, let's do 1 and 4. Okay, so number 1 says 3x plus 9 over what? X squared plus 8x plus 15. And we're going to multiply by what? X plus 5 over x minus 4. Okay, so when we multiply, we don't have to flip anything. We keep everything the same. So I just start factoring the top and the bottom. So if I factor the top, what number can I take out from both of these? What number will divide both 3 and 9? It would have to be a 3, right? So I'm going to take out a 3. So now what am I left with? Well, I need an x to get back to 3x. I need a plus in the middle. And what can I multiply by 3 to get to 9? What can I multiply by 3 to get to 9? A 3, right? Because 3 times 3 is 9. So that's the top of the fraction. Let's do the bottom now. On the bottom, I have x squared plus 8x plus 15. I need to multiply to 15 and add up to 8. So that's going to be 5 and 3. X plus 3, x plus 5. And I'm still multiplying by x plus 5 over x minus 4. The second fraction hasn't changed because we can't really factor the top and the bottom anymore. Okay. Now, what's the same on the top and bottom? What can we cancel out? Well, we can cancel out the x plus 3's, right? Because those can cancel out. They're the same. If there's ever the same thing on the top and bottom, you can cancel them out. And what else can cancel out? The x plus 5's, right? So those are gone. Now, what am I left with at the top? I have a 3. And what am I left with at the bottom? The x minus 4. I can't do anything else, so I'm done. Okay, let's try number 4. And I'm going to need a separate sheet of paper for this. All right, let's do number 4. Okay, I got x squared plus 3x minus 40 and x squared plus 2x minus 35. And everything is being divided by what? X squared plus 2x minus 48. Yeah. And what's on the bottom? We have x squared plus 3x minus 18. Okay, so we have a lot of factoring to do, right? Let's do that first. So on the top of this fraction, what will multiply to negative 40? Some kind of 8 and 5, right? Which has to be negative. Well, since I'm adding up to a positive 3, that means the smallest number has to be negative. So I can write this as x plus 8 and x minus 5. On the bottom, I know I have to multiply to negative 35, so I need a 7 and a 5. Which one has to be negative? Well, the 5, of course. So x plus 7 and x minus 5. And that's because I need to add up to a positive 2, right? So the biggest number has to be positive. Smallest number has to be negative. Okay. And we're still dividing. So I'm going to keep that division symbol right here. And I'm not going to flip it yet. Now, let's factor the top. I'm going to have x, let's see, 8 and 6. So the 8's going to be positive. The 6 is going to be negative. On the bottom, I have, let's see, I can use 6 times 3. The 3 has to be negative. Yep. X plus 6 and x minus 3. That'll work. All right. Now, since we're dividing, the next thing we do is we flip, right? We always flip the second fraction, and we keep the first fraction the same. So let me rewrite the first fraction. I'm not going to change anything to it. I'm just writing it out again. And I'm going to change the division to multiplication and then flip this. So you have to do both at the same time. You need to be able to flip and change the sign from division to multiplication. X plus 8, x minus 6. Okay, so now we start canceling out, right? What's the same on the top and bottom? The x plus 8's, the x minus 5's, and I think that's it. There's nothing else that we can cancel out. So what do we have on the top? We have x plus 6 times x minus 3. And on the bottom, what do I have? I have x plus 7 then x minus 6, and I'm done. There's nothing else that I can cancel out. The factors have to be the same to cancel them out. So the x plus 6 is not the same thing as the x minus 6. Okay, those are two different things. All right.